This diagram shows the current mobile network. In the coming years, new high-frequency bands will be allocated, making it necessary to deploy numerous mobile base stations and install new optical fibers. This is time-consuming and costly. To address this issue, NTT Access Network Service Systems Laboratories has studied the introduction of passive optical networks, PON, to a mobile network. In a PON, one optical fiber is divided by an optical power splitter so that it can be shared by many customers. When a PON is applied to a mobile network accommodating a large number of RUs, it will be possible to reduce the number of optical fibers that need to be installed. The PON was initially conceived and developed for FTTH. If it is applied to a mobile network without modification, it can cause a delay on upstream transmission, and thus the requirements for a mobile network cannot be satisfied. This is a PON for FTTH. First, the ONU sends a transmission request to the OLT. The OLT calculates the appropriate upstream transmission timing using dBA and notifies the ONU of it. Accordingly, the ONU sends an upstream signal. The ONU's waiting time for this purpose is about 1,000 microseconds. This waiting time is too long and must be reduced by a factor of 10 or 20 because the requirements of a mobile network are to be satisfied. For this purpose, NTT Access Network Service Systems Laboratories has newly developed a cooperative dynamic bandwidth allocation and cooperative transport interface. In the cooperative dBA, the scheduling information, which is sent from a mobile base station to user equipment, is passed to the OLT via CTI. At the OLT, the dBA calculates the ONU's appropriate transmission timing based on the scheduling information and passes this information to the ONU. This can make the waiting time plunge to below 50 microseconds. Please watch a demonstration. In this system, video captured by a camera is sent to a UE in real time via a PON system. First, this is done using a dBA designed for FTTH. Although the person in front of the camera is waving her hands, the scene is not being received. Now we will switch to a cooperative dBA. The video is received and played smoothly. It has become possible to use PON in a mobile network. PON with cooperative dBA and CTI facilitates the rapid construction of mobile base stations. All that is needed is to install optical fibers beyond the optical power splitter. Thanks to this technology, it is now easy to install mobile base stations in a variety of areas, such as areas where a large number of UE will be connected, shopping malls, college campuses, and factories. Areas where it is not easy to install additional optical fibers, such as existing buildings, hospitals, and airports. And areas where a timely temporary increase in base station capacity is required, such as sports stadiums and other event sites. Thus, PON with cooperative dBA and CTI can enhance the expandability of 5G and beyond mobile networks.
PON with cooperative dBA allows for the efficient use of optical fibers in mobile networks. We have presented this technology at many international conferences, and it has been extremely well received. We are confident that this technology will make a significant contribution to the spread of future mobile networks.
The international standardization of cooperative dBA and CTI is going forward in ITU-T and ORAN Alliance. PON with cooperative dBA and CTI will be key technologies to increase the global reach of 5G and beyond mobile networks in the coming years.